So if you fuse hydrogen into helium, you get this amount of energy, this jump here. When you fuse helium into carbon, which is the next one, you get this amount. So you notice you don't get quite as much. So a star that has used up all its hydrogen and is fusing into helium, and now may start fusing helium into carbon, doesn't get as much energy, therefore it doesn't have the fuel supply, so it won't last as long. So the bulk of the lifetime of a star is it's fusing hydrogen into helium in its core, and then the rest of it follows pretty quickly. So what we see is we have going up from carbon, we have carbon, oxygen, neon, magnesium, and so on as we go up. If we were to start with large molecules, or rather large atoms like uranium, we can split them to form lead and get energy that way by going up in this. Now, if we so going up in this curve we get energy, going up this way we get energy. Notice at the very top is iron, and pretty much you can't do anything with iron. You can't fuse it to get larger ones to get energy. You can't split it to get smaller ones to get energy. It's pretty much a lose-lose situation. So for large stars that end up riding this ride all the way up, iron is the last stage. So for our sun, what we have is, imagine this is out from the star. So this is the middle. The left part is the middle of our star. The right part is the as you get closer out to the edge. And at the very beginning, when it's formed, it's pretty much 25% helium, 75% hydrogen. As it fuses hydrogen into helium in the core, we get a buildup of helium in the core. The outside looks about the same. Much of the outside, however, is not fusing, it's just hot, but it's not hot enough to fuse. So you only get the fusion reaction happening in the core. And eventually, the core fills up with helium, and this is just hot helium. It's not actually fusing, so it's not powering the star. And so things start breaking down when you start getting large amounts of helium in the core. Here's a picture of the changes that a star makes. And we start with our sun, and as it starts using up its helium, using up its hydrogen into helium, we get this helium core. So we have this helium core and the hydrogen on the outside. As we go up, it becomes a red giant. Essentially, this outer part gets sloughed off, and eventually what you end up with is just the carbon core of the white dwarf star. I'll talk about this plot in a little while. If you're talking about very massive stars, the same thing happens, except for you get an onion effect. You don't stop rather at carbon. You go from hydrogen to helium, helium to carbon, and then to sodium, neon, and magnesium as we go up. So we get this onion effect, and then we can get stellar explosions. Okay.